This video is a demonstration of how to solve a few different types of acceleration problems. To start off with, you should remember that the formula we're using, you can kind of ignore this part, is this right here. Acceleration is equal to v final, the final velocity, minus the initial velocity divided by time. Okay, so the first one will be rather straightforward. Emma starts biking from rest, and she reaches a speed of 16 meters per second. I could have also said velocity. They're kind of interchangeable in this case, in 4 seconds overall. It's a good idea to kind of identify what variables you do know in this problem. So A is equal to VF minus VI over T. Well, from rest, so when she started, she was not moving at all. That means her initial velocity, that's the VI right there, that VI is going to be 0. So I'm going to plug in 0 for that. She reaches a speed of 16 meters per second, so that's her final velocity. It's at the end what she was going. So 16 meters per second, and that took her 4 seconds. So that's her time, 4 seconds. I'm going to rewrite this equation with that a little bit cleaned up here. A is equal to 16 meters per second divided by 4 seconds. Because seconds is in the denominator here and then it's being divided by again here, it actually doesn't cancel out. This is the case where you're basically putting that seconds in the denominator again, which means that simplifies to 16 divided by 4, that is 4, and meters per second squared. So that's how we get meters per second there. So that's your answer for the first part, is her acceleration is 4 meters per second squared. She then notices a big pothole, so she slams on her brakes. She decelerates to 1 meters per second in 1.5 seconds. What is her deceleration? Let me erase this. So what we know in this, 1 meter per second, that's what she came to at the end of the problem, so that would be her final velocity. 1.5 seconds, that'll be her time. And I'm asking you to solve for her deceleration. The other thing you need to realize is that you're using the information from this problem. She had reached that speed of 16 meters per second, so that is still her, or now that has become her velocity initial in this problem. Notice it was the velocity final in the first part, now it's velocity initial. So A equals VF minus VI over T. And our acceleration equals V final, that's 1 meter per second, 1 meter per second minus 16 meters per second, divided by time, that was just 1 second. Well, hopefully you can all do 1 minus 16. That gives you A is equal to negative 15 meters per second. That's a velocity because it's telling you the direction is going backwards, and you divide that by the 1 second. I'll do this in 2 steps, sure. 1 second. So negative 15 meters per second is the same as negative 15 meters per second squared. So that was her deceleration. Notice it's a pretty high number. That means that her speed changed very fast, which makes sense if you're slamming on your brakes. Last question here is a little more difficult. She starts speeding up again, this time accelerating at a rate of 2 meters per second squared. So what I just told you right here, that is her A, her acceleration. I'm asking you, how fast will she be going after 8 seconds? 8 seconds, that's our time. How fast will she be going? That's asking for her velocity final. And you need to use the velocity initial from this problem. Remember, that's what she was doing at the end of this problem and the beginning of this problem. So that's now her velocity initial. So So let's write that out. What makes this one a little more difficult is you're going to have to rearrange the different sides of the equation using some algebra. So A is equal to VF minus VI over T. And how fast will she be going after 8 seconds? Okay, sorry, I was reading this myself. The A that she has is 2 meters per second. So notice that I'm not drawing the arrows anymore about how each goes in here. Hopefully that's something that you don't have to do every time. You can if you want, but I'm just gonna go ahead and plug everything in here. VF is what we want to know, minus V initial was 1 meter per second. 1 meter per second divided by a time of 8 seconds. 8 seconds. So this is going to take a couple steps to solve this one. First, I need to get, if I want to get V final by itself, I need to get rid of both of these things. The first one you want to get rid of is the division in terms of order of operations. So hopefully that sounds familiar from your math teachers. Multiply both sides by 8 seconds. That cancels out all of that. Seconds cancel out one of the seconds here. The math you do is 8 times 2, so that gives you 16, and our units left are meters per second equals VF minus 1 meter per second. Now, order of operations says we can get rid of this, so I will add 1 meter per second. I will add, put it over here, 1 meter per second. So that gives me a total of 17 meters per second is equal to velocity final, because that cancels out over here. So if Emma accelerated at a rate of 2 meters per second squared for 8 seconds, starting at 1 meter per second, she'd be traveling 17 meters per second at the end there. So these are a few different styles of how you solve different kinds of acceleration problems. I'm hoping that helps you with those types of problems.